Evolution is a process that shapes life in countless ways, often leading to surprising similarities across distant species. Imagine a creature with thick, armor-plated skin and a shell-like back. If you thought about turtles, you'd be right. If you guessed armadillos, you'd also be right. And if you thought further back, maybe to an ankylosaur or a glyptodon, you'd be right. Again. Now, we know these creatures lived in completely different times, separated by millions of years, but side by side, looking at their anatomy, you might think they somehow share a branch or two in their family tree. Surprisingly, you'd be wrong. Despite their similar defense mechanisms, these animals have no close evolutionary ties. So, how is that possible? Turns out, nature has a way of repeating itself. Across the ages, species that never met, never shared the same land, or even the same era, ended up looking and acting remarkably alike. This mysterious phenomenon is called Convergent Evolution. In evolutionary biology, convergent evolution describes the process where distantly related organisms independently evolve similar traits to adapt to similar challenges. Now that might sound like a bit of a word salad, so here's a simpler way to think about it. Convergent evolution is like two students getting the same answer on a test. It's not because they're related in any way, but because they figured out the same solution to the same problem, independently. See the parallel? It's exactly what happens when animals evolve similar traits, like shells and armor, while facing similar survival challenges, even if they're worlds apart in every other way. And why do shells keep appearing? Well, it's because, like students who pass the test with the right answer, animals that develop this shell solution were better equipped to survive and thus pass the test of survival, pretty much. Over time, convergent evolution has given rise to remarkable examples of animals that resemble each other in both appearance and lifestyle, despite having no common ancestor with those traits. Take, for instance, the peculiar case of leaf-eating mammals. What kind of test did life throw at them, and what was evolution's answer? Well, some leaf-eating mammals evolved to eat low-energy, nutrient-poor, and even toxic diets of leaves, which pushed them to adapt in surprisingly similar ways. These mammals, like sloths, koalas, and pandas, all became incredibly slow in every sense of the word. They developed sluggish metabolisms, slow movements, and specialized bodies just to conserve enough energy to survive on their restrictive diets. In this case, the right answer was to slow everything down, and those who did, survived. This same evolutionary principle has led to one of the most fascinating patterns in the animal kingdom: creatures evolving to resemble turtles. Across vastly different periods and habitats, we find groups like the placodonts, saurosphargids, glyptodonts, and ankylosaurs, all developing turtle-like bodies and protective armor. Just as some herbivores evolved to conserve energy and avoid predators, these creatures became walking fortresses, converging on a turtle-like solution to survival. But before we dive into these lookalikes, let's explore the evolution of turtles themselves, the original armored species. I think we can all agree that they boast one of the most impressive adaptive traits of all time, one that evokes more of a Pokemon than a real species, although it wasn't always the case. Turtles first appeared over 200 million years ago during the late Triassic period. Their ancestors began developing a unique body structure, with broad, flattened ribs that gradually fused together to form a protective shell. Unlike most creatures that evolve armor over millions of years, early turtles quickly diverged from their closest relatives, creating a body plan that remains largely unchanged today. Their rigid shells provided protection and stability, allowing turtles to survive environmental shifts, predators, and competition across continents and epochs. Over time, this durable design helped turtles adapt to an incredible range of habitats, from swamps and rivers to oceans and forests. The evolution of turtles set a benchmark for armored defense in the animal kingdom, one that other creatures would unknowingly emulate through this peculiar phenomenon that we call convergent evolution. Convergent evolution gave us many turtle lookalikes over the ages, starting with the placodonts. These were a unique group of marine reptiles that thrived during the Triassic period, around 240 million years ago. Originally, early placodonts were agile swimmers, but over time they evolved a heavier, more robust body structure, adapted for life on the seafloor. Their most distinctive feature was their broad, flat teeth, ideal for crushing shellfish and hard-shelled prey, which were abundant in their coastal environments. You might wonder then, how they ended up resembling turtles. It's quite simple, actually. As their seafloor diet demanded more protection from predators, some placodonts developed their own solution to the test of survival: bony plates along their backs, which eventually resembled the armored bodies of turtles. This shell-like armor provided a vital defense against the large predators of their time, allowing them to feed and thrive in relative safety. Following the placodonts, another group of Triassic marine reptiles, the saurosphargids, took their own evolutionary path toward turtle-like armor. Saurophagids also lived around 240 million years ago during the Middle Triassic, inhabiting shallow coastal waters where they likely foraged for small marine creatures. Unlike the solid, domed shells of modern turtles, saurophagids developed a mosaic of interlocking bony plates along their backs and sides, creating a flexible yet protective covering. This armor served as both a shield against predators and a structural support for their semi-aquatic lifestyle. Though their armor wasn't as rigid as a true shell, it echoed the turtle-like design of placodont's, revealing yet another instance of convergent evolution. But was there more than just reptiles that evolved like turtles? Of course there was. Moving forward in time, we find another turtle-like creature, this time among mammals, the glyptodonts. Unlike the Triassic marine reptiles, glyptodonts roam the terrestrial landscapes of South America during the Cenozoic era, millions of years after the dinosaurs. These prehistoric relatives of modern armadillos evolved massive, dome-shaped shells composed of bony plates fused tightly together, creating a near-impenetrable shield. Some even had clubbed tails, which they could swing as a powerful weapon against predators. Unlike the flexible armor of saurophagids, glyptodonts had a rigid shell that provided robust protection on land, where they grazed on vegetation. Although glyptodonts were mammals, not reptiles, their armor was yet another example of convergent evolution, as they independently evolved this turtle-like defense to survive in predator-rich environments. Their shell-like bodies allowed them to thrive until the end of the last ice age, making them one of the most striking examples of nature's recurring solutions to survival. Now, I know what you're thinking. What about the dinosaurs? Did they too find a way to replicate the turtles? Of course they did. The ankylosaur, or as I like to call it, turtle on steroids. This beast adds yet another chapter to the story of turtle-like evolution. These heavily armored dinosaurs thrived during the late Jurassic and Cretaceous periods, walking the Earth tens of millions of years after placodonts and saurophagids had disappeared. Unlike the other turtle lookalikes, ankylosaurs were fully terrestrial and equipped with an impressive set of defenses. They developed a sturdy, low-slung body covered in thick, bony plates called osteoderms, creating an armored shield much like that of glyptodonts. And just like them, many species of ankylosaurs also had a clubbed tail, which could deliver a devastating blow to would-be attackers. Their armor provided excellent protection against the fearsome predators of the Cretaceous, such as large theropods, and their resemblance to turtles was another outcome of, you guessed it, convergent evolution. So what have we learned today? We've seen how the same evolutionary pressures can lead creatures from vastly different backgrounds to converge on similar solutions, much like students who've studied enough tend to converge toward the same answer. Each of these animals, in its own era and environment, independently developed turtle-like armor as a defense against predators and environmental challenges. Convergent evolution, as we've explored, shows us that while life on Earth is diverse, the solutions to survival often echo across time. These remarkable examples remind us of nature's creativity and its consistency. The armor that evolved in turtles, and again in these other creatures, stands as a testament to the power of adaptation and the resilience of life. So next time you see a turtle, show it a bit of respect, as it's the pioneer of one of evolution's most successful designs. Thank you for watching, and until next time on PaleoPath.